Welcome back to the GCSE Maths Pro YouTube channel. Today's video is the fourth part of trigonometry where we'll be looking specifically at the cosine rule. Make sure to check out the previous video if you haven't, where we did go through sine rule as well, and this part of the topic is for higher tier only. So if you have seen the previous video on sine rule, you'll have seen this already. This is just how we label our triangles. Sine and cosine rules are different to SOHCAHTOA because we're no longer working with right angled triangles, okay? So if you get a question in your exam that's just like a random triangle, like a scalene, isosceles even maybe, it's just not a right angled triangle, you might need to use sine and cosine rule, one of the two. In this case, because obviously there aren't any hypotenuses, there aren't any opposites adjacents, we're just using A, B and C, and that's what you'll find in the formulas, which will be on your formula sheet. It doesn't particularly matter which angle is A, which angle is B, which angle is C, as long as you label the opposite side with the lowercase letter. So angle A is the uppercase, and side A has to be the one opposite, so it has to be lowercase a here, as you can see obviously for B. Angle B is here, side B has to be over here, and C as well, obviously opposite angle C. So here we have the two versions of the cosine rule. Again, with trigonometry we can look for sides or we can look for angles, hence why there's two versions. Normally in your formula sheet I think you're given this first one, in which case either you've got two options. If you have to use cosine rule to find an angle, you'd either memorise this version, or just be confident enough with rearranging that you can take this one and rearrange it to get cos A as the subject. Whichever one you prefer, that's up to you. Now, with cosine rule, we're going to use it when we have three sides and one angle. As I said in the previous video, with sine and cosine rule, you're going to have four pieces of information, not three. So SOHCAHTOA, you normally have three, don't you? With sine and cosine rule, we're going to have four. That's including whichever is missing, so whichever side or whichever angle they want you to calculate in the question, that's included. In this case, with cosine rule, we're going to have three sides and one angle, okay? So sine rule was two sides, two angles, so like two pairs. In this case, you've got three sides and one angle. Normally, so for example, A here, if we're trying to find out A, we've got two sides and we've got the angle between them, and that's how we find A. Okay, so you might need to rearrange it, but you've got three sides and one angle. So feel free to screenshot this. For your revision, as I said, it will be in the formula sheet, but only probably one version. So let's get straight into the questions. Again, you'll need a proper scientific calculator for these types of questions. Your phone calculator will not work properly, so please don't use that. Get used to using your proper maths calculator before the exams. So here we've got work out the length BC to one decimal place. We're going to start by labelling the sides that are relevant. In this case, because it's cosine rule, we need three sides. So obviously BC is relevant because I actually want to find that out. That one is opposite angle A, isn't it? So that's side A. And then I know that I need the two sides that surround the angle. So this one would be side B because it's opposite angle B, and this one would be side C as it's opposite angle C. Once you've done that, we're just filling out the formula because I've got the formula here on each question and it will be in the right format. So in this case, we're finding a side. So I need to have the side version. So I've got A squared equals B squared plus C squared. It doesn't really matter which one is B and C as long as the two of them are correctly B and C. It doesn't matter which way around they go. Minus, now I'm going to write it down how I type it in my calculator. 2 times B times C times by cosine of the angle between them, which is 75, and then close both brackets. So make sure to grab your scientific calculator and type this in. I would just type it in all at once. You can type it in parts if you want, but I think this is easier. 2 times 19 times 26 times cos, remember it's now cos, not sine anymore, double bracket closed, equals that. Now, you're going to get a number like this, which is really big. If you have a look, because I really want you to, with trigonometry especially, just start thinking about, okay, yeah, but look at my answer. Does it seem realistic? Because sometimes you can get an answer, not realise that there's a mistake, and not pay attention to whether the number is clearly not the right answer. Here we've got side length 26 and side length 19, so I'm looking for something within that realm, right? Something that's probably less than 50. I know that none of it's drawn accurately, but if this side comes out as 780, you can kind of think, yeah, that's not reasonable. The reason why I write down A squared equals, I write down the full formula, is because this is A squared, this is not A, right? So A squared equals 781, point whatever it was, dot, dot, dot. But with cosine rule, you have to then square root. Okay, you have to square root to get an actual side length that seems reasonable. So square root symbol, answer. Okay, don't cut off any decimals, don't round it too soon. Now this seems more reasonable, doesn't it? It's within the realm of 26 and 19. So that is the answer. 27, and now we want to round it to one decimal place, so 27 would actually round up to 28.0, wouldn't it? 28.0, you have to put the 0 there. I know it seems a bit pointless, but if they want one decimal place, you have to put one decimal place, right? So there you go. Your answer is 28. It seems like a reasonable answer. So just don't forget, you do have to square root your answer at the end, okay? But that's it. Other than that, it's just, again, a bit more substitution. So let's look at the next one. Okay, this time we want to work out the angle BAC, which is angle A. So we want to work out this angle here. Obviously, I put the rearranged version of the formula there because we're trying to find out the angle. So we need to label our sides. We've got angle A as the one we want to find out. So therefore, this one has to be side A. And same as before, this one's side B, it's opposite angle B. And this one is side C, opposite angle C. So now I'm just going to fill out this version of the formula. So I've got cosine of angle BAC equals B squared plus C squared minus A squared this time. Now we actually have A over 2 times B times C. And that's what I put in my calculator. Okay. Now you can see I've got an answer, 0.65. Again, we're working out an angle. Same with sine rule, same with SOHCAHTOA. When you're working out an angle with trigonometry, or some version of trigonometry, you're going to have to do the inverse, so the -1 version of sin, cos, or tan. In this case, obviously cos. So 0.65 is obviously not degrees. It's the answer to cos of the angle. I want to get rid of the cos effect, so I need to do shift cos, so that gives me the -1 version. Click answer. Okay, so don't cut off any decimals, just click the answer button, it will copy everything. And then I've got my answer. That's actually an angle. That seems more reasonable, doesn't it? Again, we want to think, does our answer seem reasonable or have I missed something? So angle BAC to 1 decimal place is 48.8. There we go. So in this case, when you're finding a length, you need to square root. When you're finding an angle, just remember to do the cos inverse. Okay, let's have a look. This example is similar to find a length. The only thing I wanted to show you here. So we're trying to find out, work out the length of AB to 3 significant figures. So AB is obviously this one. The only thing I wanted to show you here is, particularly with cosine, it doesn't really matter with sine rule so much. Particularly with cosine rule. See how we've got a lot of different letters and it's based around angle A. Do you see how in this case, angle A is actually this one? Now, if we were to set it up, you can see we've got 2 sides and the angle between them, and we want to find the opposite side. It's still the same cosine rule scenario. The only thing is the letters are in the wrong place. Now, instead of changing this to C and then going, yeah, okay, well, if that's C, then what else changes? And that has to become C, and then, but then that can't be C, and then that's A, and then that, you know what I mean? Like, instead of changing the actual formula, you can always, if they've got the wrong letters in the wrong place, or just completely different letters, sometimes they use PQR for some reason, you can always cross it out, scribble out the letters they've used, and then go, right, I know that cosine rule is normally based around having A as the angle. So I'll put A there, I know that the opposite side, the one I want, is lowercase a. Now B is fine, so this is side B, isn't it? And the other one, I'll just change it to C. Just so it matches up with my formula and I don't have to change the formula. Because it can be so easy to change certain bits of my formula and mess it up and change half of the letters and get them mixed up, and then, you know, don't change the formula, change the labeling. Now I've done that, this is just the same example, isn't it? So obviously they've said find length AB, I've now changed it to BC, right? So A squared equals B squared, which is 42.1. Don't forget any of the squares, right? It has to have the square. C squared is now 35.6 minus 2 times B times C times cosine of angle, now angle A. Okay, and we'll type it in. Equals, and again, remember that is A squared, so I do need to square root my answer. So A squared is 3,560. And then I'm going to do square root answer because I don't want to cut off any decimals. Don't round it too soon, okay? Never round anything until the literal end of the question, the answer. So 3 significant figures would be 59.7. And there's your answer. Okay, so this was just an example to say, you need to change the letters on your diagram to match with the formula, do that. Okay, this is our last one. It's quite similar to the one we saw with sine rule, except obviously now we're doing cosine rule. But we have got 2 triangles. When you're given 2 triangles stuck together and you know it's obviously sine or cosine rule, it could be 2 of the same one, it could be 1 of each of those. You just know you're likely going to have to do 2 steps or 2 sets of working out instead of 1. So we want to find angle ADC. So that is this angle here. Now you can see we've got the 2 sides and then we want to find the angle between them. Okay, just added in the formulas there so that we have them. We are looking for angle ADC, so that's this angle here. You can see we've got the 2 sides and we want to find the angle between them. So when we look at the formula for the angle, we've got 2 sides and the angle between them. We therefore are missing a 3rd side, aren't we? Because to find the angle, I need all 3 sides. So that tells me, and it is most likely going to be, that I need to find AC, i.e. the side that both triangles share. Now, I can't start off with that because I don't have it. I therefore need to look at the other triangle on the left and deal with that one first. So the triangle on the left, ABC, I've got angle B. I want to find the opposite side, which is this one here, and I've got the 2 sides with the angle between them. So I'm going to be using the top formula. Now again, same with the previous one, I'm going to change it so I've got this as angle A because it matches my formula. That's therefore side A, this can be side C, and then we'll change this one to B. So if in the exam it doesn't match up to the formula, just change it so that you know it works. Okay, so step 1, we're going to be finding this side in the middle. So we've got a squared equals b squared, which is 6.9, plus c squared, which is 9.8, minus 2 times b times c, times by cosine 79, which gives us 117.8. Again, remember that is a squared. It is not the final answer for A. So I need to square root answer. Again, don't ever round anything until the end. So that side in the middle that they both share is 10.855. Again, I'm just going to write down a couple of decimal places, but I will keep that answer in my calculator for later. Okay, so this one is now 10.855 ... So now that I've got that side, I can go back to the actual triangle that I want, and using this formula, step 2, I'm going to label again. Again, we don't have anything in the right place, do we? So I don't want D really. I'm going to label that one now to be angle A. That's still therefore side A. And then this can be side C and this can be side B. Okay, so just relabel it. So because we're finding the angle, I've got cos of angle ADC equals to 17.4 squared plus 18.6 squared minus a squared, which I'm writing down 10.855, but again, remember you're going to use your answer button, over 2 times 17.4 times 18.6. So I've still got my answer here. Okay, I'm just going to type all this out without changing that previous answer. Minus answer squared. Okay, so in my calculator I'm using answer squared. Okay, again, I'm trying to find an angle, so I know I'm going to get an answer that's less than 1, 0 point something. I need to then remember to do cos inverse of my answer again. Use your answer button as much as you can. So the actual angle is 34.9 to 1 decimal place. And there's my answer. So I've just had to use cosine rule twice. Once I had to use it to find a side, once for an angle. As long as you label sides correctly, you should be able to figure out which is which. As I said, they might also mix in one with sine rule, one with cosine rule. Just remember, sine rule is 2 sides, 2 angles. Cosine rule is 3 sides, 1 angle. Okay? Once you've labeled it correctly, you should be able to figure out it will only stick into one or the other. So that is everything on sine and cosine rules. The final part of trigonometry is finding the area of a triangle, which is not half base times height. So thanks for watching this video. If you've got any questions or comments, please leave them down below and make sure to like and subscribe.